Captain William Gordon and Lieutenant James Monsees were the number 3 Phantom in a MiG cap protecting a photographic flight overflying the airfield at Phuc Yen. About 7 miles out, the flight lead saw 8 MiG-17s coming up through the clouds towards them. A furball ensued. Gordon turned his element to attack, but realizing he was too close to launch a missile, he disengaged to gain lateral separation. Coming back into the fight, he got 2 MiGs in his Pipper and attempted to shoot 2 Sparrows with full system lock-on. Only one came off the Phantom, but it exploded near a MiG. The pilot ejected as his aircraft came apart. The fight swirled through 2 hard descending turns as the other MiGs attempted to evade. On his 3rd turn, Gordon got a MiG-17 in the Pipper for a tail shot. By the time he had selected AIM-4s, cooled a missile and listened for a tone, the agile MiG had turned to make a head-on firing attack. Gordon fired the AIM-4 with a full system radar lock-on at a range of approximately 6,000 feet. It guided straight for the MiG. As he completed his own evasive maneuvers, he saw a parachute at lower altitude, approximately 8,000 feet. There was no sign of the MiG. After over 20 years of development, the AIM-4 Falcon had its first kill. Hughes started work on their first air-to-air missile in January 1944, in response to a US Army Air Force requirement for a subsonic missile capable of intercepting bombers under Project MX-570. Although they would come to be a significant player in Cold War missile design, Hughes were actually the 5th US company to be contracted for an air-to-air missile. Their resultant system, designated JB-3 and referred to by Hughes as the Tiamat, conducted its first test launch on the 6th of August 1945, the same day that Little Boy was detonated over Hiroshima. JB-3 was a large weapon for the time, weighing 625 pounds with a 100-pound warhead. It was a semi-active radar homing missile with a range of up to 9 miles. Hughes had high hopes for the program, but JB-3 proved to be unsatisfactory in testing and was cancelled in September 1946. Despite this setback, JB-3 established Hughes as a frontrunner in air-to-air missile development, a position which would serve the company well in the post-war years. And in fact, none of the US Army Air Force's first batch of missile programs resulted in a viable weapon. So in 1946, they issued a new set of contracts. Amongst these was the Hughes MX-798, a continuation of MX-570. Again, this project had limited lifespan, being cancelled in March 1947 due to post-war budgetary constraints. Once again, the death of one program led to the creation of another. MX-748 was immediately reoriented and restarted as MX-904. The USAF now tasked Hughes with the specific goal of developing a bomber-launched air-to-air missile designated AIM-2. Bomber defense had been one requirement that they had contracted for in 1946, but they had awarded that money to General Electric, who subsequently developed the Dragonfly. MX-904 only lasted until July 1947, when the USAF downgraded the MX-904 study to a guidance system development project. But it was restored to active status in March 1948 as part of the Guided Aircraft Rocket, or GAR program. Early in 1949, the stipulation that it should be bomber-launched was removed, although design compromises introduced by that requirement would carry forward into the eventual Falcon. The GE Firebird was cancelled, leaving MX-904 as the only active USAF air-to-air missile program, and MX-904 thus became GAR-1. The problem that the USAF was trying to solve with the GAR-1 was how to stop nuclear-armed bombers penetrating their defences. Fast, high-flying, heavily armed bombers were hard to stop with cannon fire. Rockets were a partial solution, but they were inaccurate and short-ranged. Only one bomber had to get through to destroy a military target or, worse still, a city. Covering all targets would require an impractical number of defending fighters unless probability of kill and the area that an individual aircraft was covering could increase. The first ground launches of GAR-1 airframes occurred in 1948. Over the course of the GAR-1's development, Hughes modified the planform of the missile numerous times before arriving at the classic canard delta configuration of the Falcon. The original planform featured mid-body wings and tail surfaces, with the wings and tail surfaces mounted on a different plane. As the early Falcon concepts were tube-launched, this did not present a problem insofar as mounting the weapon was concerned. Further refinements to this configuration led to an interim airframe design featuring the same basic aerodynamic configuration, fitted with revised wing and tail surfaces and an extended fuselage. But the definitive GAR-1 configuration emerged in early 1951. Because it was originally intended to be carried internally in bomber fuselages and later had moved to internal carriage within an interceptor's weapons bay, the GAR-1 was a small missile. It was 6.5 feet long, with a diameter of 6.4 inches and a wingspan of 1 foot and 8 inches. By way of comparison, an AIM-9B Sidewinder is 9 feet and 4 inches long on a 5-inch diameter body. The Sidewinder's wingspan is 2 inches broader. The Falcon's 134-pound weight accounted for the semi-active radar homing guidance and control systems, the rocket motor, and the contact fuse blast warhead. The warhead was only 7.6 pounds and required a direct hit on the target to detonate due to the use of contact fusing. This did not necessarily represent a major drawback at the time when engaging non-maneuvering strategic bombers. The airframe had a hemispherical nose radome flanked by receiving aerials that looked like small nose fins. These antennae gave proportional navigation and steering signals to the elevons mounted on the trailing edges of the 4 delta wings. The contact fuse for the warhead was on the wing leading edges, which were made of fiberboard so that they would crush on impact. Powered by a thiacol solid fuel motor, its top speed was Mach 2.8 plus the speed of the launching platform, and it had a range of 5 miles. To complete the comparison, the Sidewinder weighed 155 pounds and used a 10.4 pound warhead that could be detonated by contact or proximity. It topped out at Mach 1.7 and it had a range of 3 miles. In the early 1950s, the USAF regarded each missile as an unmanned interceptor, and therefore assigned them fighter-type designations. The Falcon was the XF-98. Despite the deletion of a bomber-specific missile requirement, the USAF still envisioned 2 weapons at this stage: a missile suitable for subsonic fighters, the XF-98, and a missile suitable for supersonic fighters, the XF-98A. The 2 missile concept came from the first 2 projected platforms for the Falcon. While the F-89 Scorpion would emerge as the initial operational carrier of the missile, the first carrier selected to employ the GAR-1 in the May of 1949 was the forthcoming 1954 Interceptor, which would ultimately lead to the F-102 and the F-106. The 2 variant concept was dropped in 1955, and the Falcon was thereafter just known as GAR-1. Air launches began in May of 1951. Test articles initially lacked guidance systems and warheads. The first mock intercept with an unarmed Y-GAR-1 occurred in June when a B-25 successfully engaged a QB-17 drone. On the 21st of October 1953, a modified F-89D Scorpion launched a Falcon for the first time. Although its wingtip pod collapsed due to the missile launch, it was the beginning of a very slow process to activate the GAR-1 operationally. The Scorpion was a good candidate as a guinea pig for the GAR-1. It was a large aircraft with plenty of space and electrical power for the radar and other avionics needed to launch the Falcon. It was also in dire need of improved weapons systems. Initially designed around a complicated, short-range, radar-directed rocket battery, the emergence of the M4 Bison rendered the slow-moving Scorpion obsolete. It couldn't maneuver into a position to attack the fast, high-flying Soviet bomber. GAR-1 offered the opportunity to extend the Scorpion's effective life for a few more years until F-102s became available in quantity. Being able to hit a target from 5 or 6 miles away and up to 50,000 feet, the Scorpion reduced the impact of the launching aircraft's dynamic limitations. Initial concepts had GAR-1 stowed one behind another in the F-89's nose, but this idea was abandoned and the aircraft's wingtip rocket pods were instead altered to carry 3 Falcons per side. Firing trials continued into 1954, by which time Hughes had fired 10 missiles for 7 hits. These shots were, it should be remembered, under very favourable conditions against slow-moving B-17s travelling straight and level. On the 27th of January 1955, an F-89 successfully destroyed a QB-17 with a GAR-1 containing a live warhead, marking the missile's first successful intercept by a frontline USAF interceptor. In the March of 1954, the USAF had ordered 156 F-89H interceptors, to be equipped with 6 Falcons as part of their armament suite, representing the first Falcon launch platform to reach service. The F-89H carried its Falcons on retractable pylons in its wingtip pods, protecting the sensitive missiles from the elements. When loading or ready to fire, the missiles could be extended from the pods on their cantilever rails. Typically, a Scorpion would carry 3 radar and 3 infrared missiles. Hughes began to deliver the first production standard missiles to the USAF from its factory in Tucson in 1954, but problems with the Scorpion's E-9 fire control system and corrosion issues in the missile bays prevented operational readiness from being reached for nearly 2 years. This was achieved in March of 1956, marking the first operational interceptor-fired radar-guided AAM combination in the USAF. The Navy's rather less sophisticated AIM-7A Sparrow had entered limited service with the F-3D Sky Knight in 1954. AIM-7A was simply a beam-riding missile, but it was still radar-guided, and thus it was the first such weapon to be operationally deployed by the US. For the F-89 crew, using the Falcon was a long and involved process. The radar observer first selected a target and directed the pilot to fly on a converging course. During the final phase of the attack, the crew activated the E-9, which featured a device called the F-computer designed to manage missile attacks. The F-computer determined the best possible course from the interceptor to the target, feeding this information into the flight control system to allow the missile to launch on an optimum trajectory in a lead collision engagement. The E-9 also performed automatic armament selection, removing this function from the crew's control. If the computer judged a missile attack to result in a miss, it automatically selected the rocket armament for a follow-up engagement. 40 seconds before entering missile launch range, the missile auxiliary subsystem shut off the electric heating elements protecting the Falcon's guidance systems and transferred the missile from the aircraft's internal power supply to its internal batteries. 15 seconds prior to launch, the computer uncaged the seeker head of the missile, aligning it with the target. At this time, the missile subsystem aligned the aircraft's radar and the missile's semi-active radar homing seeker to the same operating frequency. 6 seconds prior to launch, the Falcon's seeker range gate servo aligned with the range gate of the interceptor's radar, allowing the Falcon's seeker to receive updated information. Final checks of the missile and radar system occurred 2 seconds prior to launch. The missiles were provided with instructions about the sensitivity and rate of control inputs, which varied by altitude. When the optimum point was reached, the E-9 triggered the weapons. During radar-guided attacks, the radar illuminated the target all the way to impact. Once they impacted, the pilot could maneuver. Obviously, after an IR missile launch, the pilot was free to maneuver immediately. The system never worked very well. ADC's assessment after firing trials was that even if snap-up capabilities were added, the Scorpion and Falcon combination would be very marginal against the B-52 and thus also against equivalent Soviet aircraft. But the Falcon program was a bit of a runaway train by this point, and a year before its service entry, the GAR-1 was also selected to arm the Air Defense Command's version of the McDonnell F-101 Voodoo. Even so, the GAR-1 was only in production for about a year, with the line moving on to more advanced versions in November 1956. The main difference between the improved GAR-1D and the original GAR-1A was the separation of the control surfaces from the delta wing to improve effectiveness at altitude. Based on the lessons of the F-86H, one of the key firing profiles that ADC wanted for the F-102 was a snap-up attack in which the Dagger launched its weapons as it climbed towards the Soviet bombers, traveling at speeds and altitudes well over 50,000 feet. The new rudders were actuated by rods attached to the delta wings, which is a curiously inelegant solution at odds with the tidy engineering typical of US aviation in this period. As part of these modifications, the missile body was extended by 0.2 of an inch. Gar-1D was judged to be able to hit targets flying at up to 60,000 feet. Flight trials began in 1955 and the weapon entered service in 1956, almost simultaneously with the Gar-1. This was quite surprising as the Gar-1D was effectively useless. In December of 1956, 3 F-102As deployed to Eglin for firing trials. Of 20 missiles launched at targets, only one achieved a hit. This should not have come as a surprise to the USAF, as during a conference in late November of 1956, the service criticised the Falcon missile program due to a failure rate in testing of roughly 50%. Missing drone targets was to become a feature of the Falcon. In later years, more accurate missiles like the AIM-9 exacted such a toll on drones that testers began to set a deliberate offset in the missile guidance computers so that they would pass close by rather than directly impacting the drone. This never proved necessary with the Falcon, as it rarely hit a moving target. For this reason, the range controllers referred to it as the friendly missile, because it just couldn't bring itself to hurt anything. After the latest poor performance, the USAF ordered production suspended in early 1957 to correct the obvious deficiencies. When it resumed later that year, the Falcon was only able to achieve a satisfactory rating. It was, however, too late to change course, as US interceptors had been designed with internal weapons bays sized to accommodate the Gar-1. Gar-1D thus re-entered service in mid-1958, being renamed AIM-4 Falcon under the Tri-Service Designation System. Development of the infrared-guided version of the Gar-1D began in July 1952. This weapon, initially designated Gar-2, was 1.5 inches longer than the Gar-1D due to the infrared seeker. Hughes proposed Gar-2 for the F-102 at the same time the company proposed the Gar-1D in late 1953, allowing both missiles to be implemented in the Deuce's armament suite throughout development. In July 1957, F-102 units at Eglin tested the Gar-2 as well. Predictably, every Gar-2 launch during the exercise failed. The Gar-2 used a seeker that operated in the 2 to 3 micron range, which corresponded to the emissions of the hot metal of the jet tailpipe. It was a lead sulfide sensor like that in the Sidewinder, but in this application it was externally cooled with liquid nitrogen to increase sensitivity. This was accomplished by a supply of liquid nitrogen being provided in the weapons bay of an F-101, 102 or 106. The guidance system worked via a spinning black and white reticle in front of the detector that modulated the signal being received by the detector and thus sent signals to the rudder actuators that steered the missile to follow the target. Despite the combination of advanced technologies, during continued testing of the Gar-2, Hughes determined that the IR seeker was very susceptible to external interference from environmental sources, such as haze, clouds, and the sun. The window in which a seeker can see through water vapor is between 6 and 15 microns. However, the materials and technology required to make such a sensor were not available in the early 1950s. My understanding is that the AIM-9B Sidewinder used a sensor that detected emissions in the 1 micron range, making it even more susceptible to interference. Hughes embarked on a 2-year program to evaluate and solve the issues with the Gar-2, leading to the Gar-2A. During this period, low-altitude evaluation of the weapon in 1959 illustrated that it was virtually unusable in that environment. The eventual solution was the addition of micron filters to the IR seeker in an attempt to filter out some of the clutter, although this did not completely alleviate the problem. Despite all of the issues, Gar-2A was also added to the F-89H Scorpion's fire control system and then to that of the subsequent F-89J. The J is most famous as the only platform to launch a Genie nuclear air-to-air rocket. It carried 4 Falcons on pylons as a backup in case 2 nuclear warheads somehow didn't do the job correctly. F-89J featured an improved version of the E-9 called the MG-12. This included the snap-up engagement mode that had been requested based on assessment of the F-89H. The MG-12 snap-up engagement mode required the pilot to follow cues in order to execute a straight-line climb. Launching a missile at the apex of the climb would theoretically allow the interceptor to engage a target up to 15,000 feet above it. A 1955 trial of the snap-up attack capability resulted in 3 of 5 Falcons achieving direct hits, with a fourth missile classified as a near miss. That success aside, the installation on the Scorpion notably pointed to future issues that the USAF would have with the Falcon. Hughes had designed it to be internally carried within a weapons bay. This meant that it was not designed to deal with the atmospheric heating, moisture ingress, and vibrations that a weapon encounters when it's carried externally. There was also the question of integration with the Scorpion's MG-12 fire control system. To get around the need to re-engineer the complicated analog computer, Hughes instead created a pylon that did the work of translating between the aircraft and the missile during the launch sequence. This system apparently reduced communication-related failures of the missiles, but did nothing about the overall low reliability of the combination of an infrared homing Falcon and a fighter pylon. The National Guard units flying Scorpions never used them operationally, and the pylons were eventually removed from the aircraft. GAR-2 became AIM-4B, and GAR-2A was the AIM-4C. It was never used in combat, although an F-102 did successfully shoot down a T-33 in a range accident in 1958 when it accidentally fired 3 warheadless Falcons at the unsuspecting aircraft. With typical, in this case fortunate, lack of accuracy, one of the fast-flying missiles damaged the T-33's tail and the crew had to eject at 43,000 feet. In July 1952, Hughes started work on an enlarged and more powerful version of the Falcon for deployment on the supersonic F-106. Initial design of the GAR-1A employed a modified GAR-1 planform with lateral strakes added to the forward fuselage. This configuration was revised, likely as a result of GAR-1D development, and by the end of 1954, both the GAR-1A and the infrared homing GAR-1C resembled the GAR-1D, save for the lack of canard surfaces and the inclusion of revised nose profiles allowing launch at higher speeds. Further improvements made to the GAR-1A and the GAR-1C included a new 2-stage rocket motor incorporating boost and sustain phases, and a new 28.7-pound warhead. It was still a hit-to-kill weapon, however. GAR-1C was a GAR-1A body, motor, and warhead mated to a GAR-2 infrared seeker. It therefore shared all of the weaknesses of that weapon. Maximum speed was now Mach 4, and maximum range was 7 miles. In 1956, the GAR-1A and GAR-1C had been redesignated GAR-3 and GAR-4 respectively. Testing of GAR-3 began in 1955 and it scored its first air-to-air hit in July of that year. Testing with the F-106, which began in 1959, resulted in a fairly mediocre set of results. Hit rate remained firmly below 50%. Further improvements were therefore required, and thus only 300 GAR-3s would be made. Under the tri-service designation system, GAR-3 was the AIM-4E, and GAR-4 didn't see service at all. Development of the improved GAR-3A and GAR-4A missiles began in 1954. That is before the poor performance of the other missiles had been revealed and demonstrates the pretty crazy level of overlap in the development process. Apart from enhancements to the guidance systems, the GAR-3A and GAR-4A introduced a new Thiokol M46 motor with an increased duration sustainer, and it featured further changes to the Super Falcon's aerodynamic platform in the form of wing root extensions reminiscent of those found on the 1953 GAR-1A configuration. A weatherproof sleeve enclosed the forward fuselage of the GAR-3A and the GAR-4A, protecting sensitive avionics components. GAR-4A had a new seeker operating in the 3 to 6 micron range and more powerful preamplification to further enhance its ability to pick out targets from clutter. It was a capable IR-guided weapon for the time. F-106 pilots claimed that the missile enjoyed a degree of all-aspect capability and was able to track Firebee target drones from head-on in certain scenarios. GAR-3A became the AIM-4F, and the GAR-4A became the AIM-4G. As a result of the accuracy issues encountered in the original GAR-2, in the April of 1962, Hughes began work on modifying the GAR-2A with the GAR-4A seeker. The resultant GAR-2B, or AIM-4D, was intended for use against all types of aerial targets, not just bombers. Maximum range was theoretically 5 miles, but in reality it was more like 2. It could be used down to 1,000 feet from the target, which is superior to the 3,000 feet minimum range of the Sidewinder. Having been forced to use the Navy's Sidewinder on its tactical fighters thus far, the USAF was determined to have an Air Force missile arming its forthcoming F-4D Phantoms. AIM-4D was therefore modified to be more resistant to moisture ingress when externally carried. This upgrade only covered the forward fuselage, and as far as I can establish, no vibration mounts were installed for other components. AIM-4D entered production in February 1963, with service entry coming the following July. Hughes also remanufactured surplus GAR-1D and GAR-2A missiles to AIM-4D standard to increase the usable stockpiles. The USAF conducted F-4 trials with the AIM-4D in 1965, and we'll get to its combat results later. Apparently, the trials went well enough that the weapon was deployed to Southeast Asia. In total, about 4,000 radar and 26,000 infrared homing Falcons were manufactured. The Falcon was most often carried by 3 aircraft of the Century series: the F-101B Voodoo, the F-102 Delta Dagger, and the F-106 Delta Dart. F-100s also carried Falcons as an experiment, but ultimately never went into combat with it, using Sidewinder instead, as it was easier to integrate with the relatively unsophisticated radarless Super Sabre. Similar to the Sparrow, the Falcon was developed at a time when advanced weapons were only possible when they were tightly integrated into the aircraft and its avionics. I've covered the Deuce's weapon system extensively in the past. Ignoring the brief use of MG3, armament system control was the responsibility of the Hughes MG10. This necessarily featured a great deal of automation, as the F-102 only had 1 crewman. MG10 converted digital data to analog for the pilot's cathode ray tube radar screen, and it worked with the autopilot to fly the plane on an intercept course. It locked the radar onto a target and tracked it, while its link computer calculated a collision course flight path, ideally crossing the target's track at an angle of 70 degrees. The pilot then selected appropriate missiles and began the firing sequence, which would arm and prepare the weapons. At the correct moment, the FCS opened the missile bay doors, extended the Falcons on their trapeze launchers, and fired a salvo of 3 weapons in rapid sequence. The time from system lock-on to firing was 16 seconds. In addition to calculating the fully automatic radar lead collision course, the MG10 also gave the pilot the option of manually controlled interception using either the collision course or tail chase method. The system provided a Falcon with full target information, and as in the E9, it also transmitted data such as air density at the target's altitude to fine-tune the missile's directional controls. Notably, this radar-cued launch method was used for both the semi-active and the infrared homing Falcons, theoretically improving probability of kill by ensuring that the weapons were always launched within the envelope. The downside of the system was that the IR missiles were carried in the weapons bay, so that if the Deuce was maneuvering in a lead pursuit curve, then the missile would be blind for the first moments of its flight, even if it was directed on the right initial course by the final instructions from the FCS. F-102s only launched Falcons in anger on 2 occasions. On February 3, 1967, a pair of F-102s were ambushed by 2 VPAF MiG-21s. One Deuce was shot down by an ATOL. The other launched a salvo of 3 infrared AIM-4Ds without success. 7 years later, on the 22nd of July 1974, 2 Turkish F-102s and 2 Greek F-5A freedom fighters engaged in a dogfight over the Aegean. Despite the claims of both sides, no one was shot down in the brief fight, despite a Falcon being fired by the F-102s and a pair of Sidewinders by the F-5s. F-102s also used the Falcon against ground targets in Vietnam during Operation Stovepipe. The IR sensor was used to home in on campfires lit by the transport crews on the Ho Chi Minh Trail and the hot blocks of their truck engines. After-action damage reports aren't available, so it's probably best to assume a limited success. The next aircraft to deploy with Falcons was the F-101B, which bridged the gap between the F-102 and the F-106. Functionally, its MG3-based MG13 fire control system was roughly equivalent to the MG10 in the Deuce, but notably moved responsibility to the intercept to the aircraft's backseater. The pilot merely selected the weapons at the last moments of the intercept and then pulled the trigger. The backseater didn't have a stick, and therefore he couldn't do that bit. Falcons flew with the US and Canadian Voodoos into the 80s. The F-106's MA-1 fire control system was updated to improve its teaming with the more capable AIM-4F and AIM-4G. It also featured full integration with the SAGE ground control intercept system, reducing pilot workload by flying the plane after takeoff until the intercept point, at which point the fire control system took over. Although its displays were clearer and the aircraft in general offered far higher performance, employing the AIM-4 in the F-106 was essentially the same as in previous aircraft, with the same weaknesses in terms of its usefulness against maneuvering targets. I'll spare you the suspense here. The Falcon was not an effective weapon in the air combat environment of Vietnam. There are those that will excuse its performance on the basis that it was a bomber interception weapon designed to be used in an integrated weapons system, but that isn't really true. The AIM-4D was explicitly designed to meet the Air Force's need for an infrared missile for fighters to use against other fighters. This is why it combined the lighter, lower inertia airframe of the original Falcon with the superior sensor of the AIM-4G. It was also integrated into the F-Force fire control system, providing limited all-aspect capabilities, as the report of the first kill demonstrates. By slaving the missile to the radar, the chances of the cooled sensor acquiring emissions from other parts of the target improved somewhat. There were, however, two major issues with the way in which the AIM-4 was integrated into the Phantom, besides the lack of the proximity fuse, which is a fundamental problem. The better known and probably the worst of the two issues was the warhead cooling system. The F-4 carried the AIM-4D on LAU-42A launch rails, mounted on the inner wing pylons. With 2 rails per pylon, a maximum of 4 AIM-4Ds was possible. The rails, mounted both below and on the inboard face of each pylon, didn't share the same configuration. The larger inner rail contained the nitrogen supply required to cool the sensor head prior to launch, a decision likely made to allow the F-4 to forego the lower rails in order to carry other ordnance on the pylon itself. There was only enough liquid nitrogen in the system to provide 2 minutes of cooling. Once the nitrogen was expended, the missile was useless as the sensor would be unable to detect anything. Cooling the sensor took between 3 and 5 seconds, after which the pilot had the rest of the 2 minutes available to take his shot. This issue was actually well known about before Vietnam, and a fix was in development that would have given 2 hours of missile operation, but the terrible reputation that the Falcon quickly garnered meant that it was never implemented. An associated issue with the cooling system was that a weapon that had been cooled but not fired couldn't be made ready for action again upon landing. Instead, it had to be sent back to the US for refurbishment. The second major problem with the way the Falcon was implemented on the Phantom pertained to automation, or rather lack of automation. Although the ability to obtain a full system lock-on to enhance missile lethality was available, none of the automation that the F-102 and F-106 pilots benefited from was carried over. That meant that all the steps that the MA-1 handled, such as cooling the missile, cueing it to the radar, uncaging the seeker, disconnecting it from aircraft power, and so on, had to be done manually by the pilot through a series of switch and button activations. All of those essentially required the pilot to be heads down in the cockpit, which was far from ideal in a dogfight situation. Hence Captain Gordon's comment about the MiG being able to turn around on him in the time between selecting an AIM-4 and it being ready to fire. Colonel Robin Olds was the most vociferous in his complaints about the Falcon. He fired 7 or 8 of them without result, getting more and more frustrated until the final straw was reached. In an engagement with the MiG-17, he got onto the fighter's tail, lined up a shot, pressed all the switches, waited for the tone, and fired. The Falcon zoomed away, tracking perfectly, and for a moment Olds thought that it would actually work and his concerns would be invalidated. But at the final moment, the AIM-4 suddenly went vertically upwards, then abruptly tipped back and went vertically down towards the ground, disappearing out of sight. When he got back, Olds had the maintenance techs modify the F-4Ds against orders from above so that the wing could fire Sidewinders once again. Olds' account actually points to some other of the issues with the Falcon. It was still not a missile designed to be carried on a pylon, and like other missiles in the theatre, it didn't appreciate regular exposure to the hot, wet climate and regular trips on bumpy roads. Overall, US pilots attempted to fire 51 AIM-4s in Vietnam. 7 of them didn't fire. 5 of them scored confirmed kills with 1 probable. In the same engagement as Gordon's kill, his wingman observed 2 MiG-17s at his 10 o'clock position. He cooled an AIM-4D, obtained a self-track lock-on and fired the missile with a 10 to 15 degree lead angle. It hit the MiG on the tail, the pilot ejected and his plane spiraled earthward in flames. On December the 17th, 1967, an Air Force F-4 commanded by Captain Doyle Baker, a Marine Corps exchange pilot, attempted to engage a MiG-17 with his Su-23 gun pod. The MiG turned on him and evaded the attack. Passing beneath the hostile aircraft, Baker performed a high-speed yo-yo, followed by a scissors as the MiG reversed his turn. Keeping the MiG in sight, Baker waited for separation, then performed a split S and made a second high-speed pass, firing his Su-23. But the MiG continued to turn into the attack, and Baker returned to 10,000 feet to allow separation. Making another high-speed pass with the gun, he discovered it was empty. The MiG then turned to attack. Baker overshot, made a high-speed yo-yo at 10,000 feet to try and get more separation. The MiG then leveled his wings 2,000 feet of altitude and headed 120 degrees away at approximately 0.6 of Mach. Baker maneuvered the Phantom into a 2 nautical mile stern attack and launched one AIM-4D while in a 10-degree dive, passing through 3,000 feet. The missile hit the tailpipe of the MiG, and Baker observed persistent fire and black smoke trailing the hostile aircraft. The left wing of the MiG dropped sharply, and it began an uncontrollable downward roll from 2,000 feet. On January 3, 1968, Lieutenant Colonel Clayton Squire and Lieutenant Michael Muldoon engaged 4 MiG-17s in a head-on pass during egress from a strike target approximately 6 miles north of Pak Giang. The MiGs passed within 200 to 300 feet of the Phantom, going the opposite direction. He shandelled in afterburner to the left, cooled an AIM-4 for re-engagement. After a complete turn, he visually acquired 2 MiG-17s 3 miles ahead in trail and in a gentle turn. He selected the trailing aircraft, tracked it, closed to positively identify it, and launched the AIM-4. It tracked directly to the aft section of the MiG, exploding in a ball of fire and smoke. The MiG immediately emitted a solid trail of grey-white smoke and continued in a gentle left turn before crashing. On January 18, 1968, Major Kenneth Simonet and Lieutenant Wayne Smith engaged MiG-17s. In a climbing right turn, they observed a third MiG at their 10 o'clock. Simonet reversed left, cooled an AIM-4D, and fired the missile. It went up the tailpipe of the MiG and exploded. The MiG caught on fire, went out of control, and crashed with no parachute being observed. Simonet and Smith were actually shot down by another MiG-17 just moments later, spending 5 years as POWs. Finally, on February the 5th, Captain Robert Hill and his backseater launched a pair of Falcons at a MiG-21. The first didn't appear to guide, but the second went straight up the MiG's tailpipe, resulting in a 40-foot diameter ball of white smoke and an explosion. The fish bed went straight down and crashed. 51 attempted launches for 5 or 6 kills give 9.8 or 11.5% probability of kill on trigger pull. Sidewinder and TAC Hand scored a 15% kill rate, 187 rounds fired for 29 kills. What the 5 successful launches show is that the AIM-4D did have a wider firing envelope than the AIM-9B. One of the kills is actually from the front quarter, a position from which the AIM-9 simply wouldn't guide at all. Another was in a dive at low level. Again, AIM-9B was effectively useless in low-level attacks from above, as it would just go straight into the ground. AIM-4 was also as much as 700 miles an hour faster than the early Sidewinder and had about 30% more range. But it also had that small warhead and a contact-only fuse. A proximity fuse version of the AIM-4D was also planned, designated AIM-4H, but it was never implemented. If it had been developed and further work done to automate firing, then the AIM-4 would actually have been a credible alternative to the Sidewinder. But as it was, the simplicity of the Snake, which worked as soon as you selected it and didn't require any real avionics sophistication in the launching aircraft, made it the superior weapon. The Navy had reached this conclusion some years previously when they test-fired the two missiles against each other. Hughes turned up with an extensive technical team and a batch of white-glove assembled Falcons. China Lake just brought some Sidewinders they had to hand, strapped them to the aircraft and shot them. Predictably, the AIM-9 scored a higher hit rate even under those conditions. As I say, the Falcon wasn't an especially bad missile or a bad platform. It's just that the Sidewinder proved to be a better one. And the Navy had, of course, already upgraded the Sidewinder as the AIM-9D with a sensor just as good as the Falcons, yet more upgrades were to come. The AIM-4 retired from the US inventory in 1988. Falcons also armed Swiss Mirages, and they were licensed built in Sweden as the RB-28. It armed the beautiful Draken Interceptor. For all of its faults, it was an innovative weapon, produced at a time when the idea of a guided air-to-air missile was just that, an idea. Although the compromises of its muddled gestation in terms of size, robustness, and warhead potency limited its effectiveness, The technologies that it enabled Hughes to pioneer, and in particular its plan form, were a staging point for much more powerful weapons to come.